Okay, so we're back for part 3 of our 8.3 trig modeling lesson. Previously, we took the information in the problem, sketched a graph, produced an equation. For part 2, we identified the depth of the tide at 12 hours after midnight, which was noon. And then now we're working with what I think is the hardest part of this entire problem right now is finding a time when the tide is at a certain height, kind of the reverse idea of what we did in part B. So it says a large boat needs at least 3 meters of water to moor at the end of the pier, right? So the tide depth of the water needs to be at least 3 feet. And then the question is, during what time period after noon, can it safely moor, right, in 3 meters of water? Okay. So just please note the graph that we're looking at here is the same graph we used in the previous videos. However, what I did was I extended our graph on the right side here because the question is saying, can it safely moor at 3 meters after noon, after 12 p.m., right? So our original graph went out to about 12 here. And if you looked at the section of the curve we had sketched in that area right there, this window right here, this interval on the graph itself is below our 3 meter line. I should also mention that I did sketch in 3 meters. I sketched in a 3 meter line, which is a horizontal line, just to give me a visual, and removed our line of oscillation from the previous graph, so we weren't confused, right? So right now, this blue line is not the line of oscillation. It's a measurement of 3 meters of water. So when we're looking at this interval right here is below that 3 meter line. So this window of time right now, the tide depth is not high enough for this boat to moor. So we want to look at, when after 12 p.m. is the tide high enough, which would be this window right over here. Okay, this section of the curve is all above that 3 meter line. So what we kind of want to do is figure out, what is this time interval right here, right? And how do I find it, right? So we have an equation, and we can work with this equation to identify this time interval, but it gets a little tricky at first. So what we're going to do is we're going to take our original cosine function that we created, and we're going to set it equal to this 3 meter line. And I'm going to solve it for t and hopefully find this value right here, right? So here's the work for that. We want at least 3 meters of water. So this is the original function I created, and I'm setting it equal to 3 meters. And we're just going to use some algebra to solve this equation, right? So we first subtract 3.6 from both sides. Next up, we need to get rid of the 1.6 value here. So I'm going to divide both sides of the equation by 1.6. And notice, don't round, leave 3 to 4 decimal places if possible until you're finally done here. So down here, I still need to isolate the t value. So what I want to do is I need to undo this cosine function. So I'm going to use the inverse cosine on both sides of my equation to separate cosine function from inside the group here. And once I produce that, I have this group on the left side, and then on the right side, that inverse cosine of negative 3.75 gives me 1.9552. At this point, still some algebra steps. I want to undo the pi over 6.2 multiplication to t minus 4.25. So I'm going to multiply both sides of the equation by the reciprocal here on both sides. Again, just push this into your calculator, and it approximates to 3.8586. Here, the reciprocal here simplifies with 1. And my last step here is I'm going to add 4.25 to both sides to isolate t. Now, when I do that, I get t equals 8.1086 hours, right? So just beyond 8 hours of time after midnight, okay? However, the question was asking us to find a window of time after 12 p.m. 8 hours after midnight is 8 a.m. This is not after 12 p.m. So this does not help us, but we can use it to identify that value. So let's go back up to look at the graph to get a sense of what we're actually looking at here. So on my graph, this point of intersection with the 3-meter line here and my curve, that's the value we just identified, 8.1086 hours. And this is definitely not afternoon. So what I need to do is figure out what this value is. This is the first time after 12 p.m. where the tide is going to be above that 3-meter line. So the question is, how do we figure out this time, right? Fortunately, there's symmetry involved in the sine and cosine functions, which can help us, identify other values. For example, this bottom section of the curve right here is symmetrical at this minimum point here, which is at 10.45 hours and 2 meters, right? So I can use that symmetry to help me figure out some other time intervals, right? So when I say this minimum point of 10.45 hours is symmetrical, is that symmetrical point, meaning that this section in red right here on the 3-meter line is the same as this section in green right here on the 3-meter line, right? So how do we find this section in red, right? What's that length of time? So we do know this value, 8.1 hours, and we do know this minimum time at 10.45 hours. So a little subtraction helps me find this time interval right here, right? So that's what I'm doing right over here on the left. 10.45 minus 8.108 hours gives me 2.34 hours. So this measurement right here is 2.34 hours. Because of symmetry, that means this green segment right here is also 2.34 hours as well. So what I can do now is I can take this 2.34 hours right here and add it to the 10.45 hours right here. And that'll give me this interval of time right here, which is what I'm looking for. That's going to be the first time where this tide is above 3 meters, right? So how do we do that, right? So 10.45 plus the 2.34 hours we just identified gives me 12.79 hours, which means after midnight, 12.79 hours right here is going to be the first time that the tide is above, it's going to be the first time after 12 noon that the tide is above that 3-meter line, right? But the question is asking during what time period, right? So unfortunately, we're not done yet. We need to find that interval of time, right? So go back to the sketch I had, right? So now here's the segment, right? So now the tide is below 3 meters. It's going to stay below 3 meters until that 12.79 time. And once it hits that time interval, now it's at 3 meters and it starts increasing above 3 meters. And then eventually the tide starts dipping back down and it's going to go below that 3-meter line right here, right? So this is what we're looking for. How do I find that 21.51 hours right here? So again, this is a lot of number sense and logic, to be honest. And this is where the visual of the graph really is helpful. So making it sketched, at least to scale, doesn't have to be perfect. It's going to be your best friend at the moment. So let's just take a look at some things. So I do know this time right here, which is 12.79 hours right there. Oops, let's move the other one. All right. Oh boy. Okay, so this time interval right here is 12.79 hours, right? And that's from midnight, which is all the way at 0 hours, right? I also know that the first time interval we found was right here, which was 8.1086 hours. So I can use a little bit of subtraction here, where I can subtract this 12. 0.79 hours, which is right here. I can subtract that. I can subtract 8.1 hours from that time interval, and that'll give me this measurement of time right here. Okay. And how is that going to help us, right? Right. So when I do that subtraction, I get 4.6814 hours, which is the length of this time interval right there. But how's that going to help us? So you got to think a little outside of the box right now. From this point right here, 8.1 hours, the curve kind of bends down and then comes back up. And vertically, you know, there's no symmetry here, right? This section is not as deep. The distance from this 3-meter line to this minimum point here is not the same as the distance from that 3-meter line to the high point right here. They're different symmetrically that way. But what I do know is from this point of the curve right here, all the way until it goes back up over the 3-meter line and touches it again. This point here to this point here, this is one period, right? Even though it doesn't look like a typical wave that we graph, this is still one period of time right here. So if I know that that is 12.4 hours, and I know this interval of time right here, which is 4.6 hours, I can find this piece of time right here, again, with some more subtraction. So what I'll do is I'm going to take the full period, 12.4 hours, subtract this interval of time, which is 4.6 hours from it, and that's going to give me 7.7186 hours. So this window of time right here from 12.79 hours, I'll have at least 3 meters of the water to work with for about 7.7 hours here, right? So how do I identify that as an answer right now, right? So, you know, the best way to really do this is if I add 7.7 hours to this initial, this time right here of 12.79 hours, remember, this is the first time that the tide is above 3 meters after 12 p.m. I'll end up with this time here of 21.51 hours, right? So my window of time for this section of the curve right here is going to start at 12.79 hours. And then what I'm going to do is I'm going to add that 7.7 hours to it. And it's going to take me to 21.51 hours. So that's going to be my interval of time. So down here at the bottom, I have that. So the boat can moor in at least 3 meters of water in the interval of time from 12.79 hours all the way up to 20.51 hours here. Now, I know this is a lot, which is why I broke it into 3 chunks. First chunk being the most critical, which was the first video of just sketching the data, identifying if you want to sine or cosine, finding the information that you need to produce that function. The second part is I would say the easiest once you have the function, where you're just plugging values in to the equation you wrote and identifying the depth of the tide. The third part here is finding time intervals or times when in this case, the depth of the tide is at a specific height there. So you're gonna have a worksheet tonight to work on. It kind of reviews all these concepts. Not too many questions, but it does take a little time, and I highly encourage you to practice it tonight.